Welcome back. This is Module 3, Lesson 1. We're going to be looking at integer sequences. Should you believe in patterns? Mrs. Rosenblatt gave her students what she thought was a very simple task. What is the next number in the sequence 2, 4, 6, 8? Cody says, I'm thinking of a +2 pattern, so it continues 10, 12, 14, 16. Allie, I'm thinking of a repeating pattern, so it continues 2, 4, 6, 8, 2, 4, 6, 8. Suri, I'm thinking of the units digit in the multiples of 2. So it continues 2, 4, 6, 8, 0. That's the units digit for 10, 2, 4, 6, 8, and 0 would follow here. So this question says, are each of these valid responses? Well, we're going to have to say yes, because we can at least think of a way that each of these were 100th term in the sequence of Cody's scenario, Allie's, and then Suri's. Well, Cody's going up by 2's every time. First term is 2, the second term is 4, the third term is 6, the fourth term is 8, the fifth term is 10. 2 times 1, 2 times 2, 3 times 2, 4 times 2. So if we want to know what Cody's 100th term is, and we write it like this, Cody 100, to show that we're thinking of the 100th term in his sequence. This would be C1, C2, C3, C4. C5 is 2 times 5, C6 is 2 times 12, so we could guess that Cody's 100th term would be 200, and we would be correct. All right, Allie. So we want to know now what is the 100th term in Allie's sequence. Well, let's see here. Allie's sequence goes this way. A1, A2, A3, A4. A5, let's see here, let me write this. A1, A2, so we don't get confused, A3, A4, A5, A6, A7, A8. What we can see is that when we get to A4, the pattern repeats. So if we take 100 and divide it by 4, 100 divided by 4, we get 25. And there's no remainder, which means that this pattern will repeat 25 times and always ends on an 8. So Allie's 100th term will be an 8. Now Suri. So Suri changed this up a little bit. And what she did was she added a fifth term, S1, S2, S3, S4, S5. So we would predict the next 0 would be at S10. And since 100 is a multiple of 10, we can see that Suri's 100th term will be 0. What is an expression in terms of n for the nth number in the sequence of Cody's scenario? Well, all Cody did was take the number, the position of the number n, and multiply by 2. That's what we should expect. The last example, we saw numbers being added by 2, but Jerry thought of a pattern that shows powers of 2. 1, 2, times 2, times 2, times 2, times 2. It says write an expression for the nth term of Jerry's sequence. Well, let's go ahead and do a little bit of thinking about what we're looking at here. A sub 1 in his term is 1. His second term is 2. The third term, fourth term is 8. The fifth term is 16. And we say this A sub 6 because the 6 is below it, but it's indicating the 6th position, which is 32. So what we see is that every time something happens, basically what he did was he multiplied by 2 times 2 times 2 times 2 times 2 times 2. Now the part that's a little bit confusing is how do we get this 1? We can see that it's just 2 times whatever is going to happen. So if we want to get what's called, if we want to find the nth term, if we want to know A sub n, this is 2 to the first power. 4 is 2 to the second power, 8 is 2 to the third, 16 is 2 to the fourth, and 32 is 2 to the 5th. 2 times 2 is 4, 2 times 2 times 2 is 8, times 2 again is 6. This first term must have been 2 to the 0. So if we want to know what the nth term is, what we're going to do is we're going to have to say a to the, and this, if you notice, 0 is always 1 less than the number we saw here. 2 is less here, so we're going to say to the n minus 1. If you think about it, let's try it with a sub 4. What does a sub 4 equal? A sub 4 would be 2 to the 4 minus 1. And 2 to the 4 minus 1, that's 2 to the 3rd, which is 2 times 2 times 2, which is 8. And voila, that is exactly what we were looking for. So this is, whoops, that's not the one I wanted to do. Let me get rid of that, and we want to circle this guy. This is an expression for the nth number in Jerry's sequence.